Hey, good morning, everyone. Okay, so kita start lah. So today kita akan masuk chapter 3, okay? This week is chapter 3. Basically, chapter 3 is for 3 weeks. Okay, lama. 3 minggu ni baru kita dapat kasi habis. Sebab dia ada a few subtopics. And then, based on my experience, this chapter yang mostly students ada problem lah. Okay? Dia simple tapi ada certain subtopic yang macam a bit difficult lah. Okay, so the first subtopic is on electrical current. So electrical current ni dia basic je lah. Dia basically suruh kamu apply electric current punya formula. Electric current punya formula pula is just I equal to Q over T rasanya. Yeah, Q over T. Okay, so basically this is the rate of change of current lah. Okay, so unit untuk current kamu tahu it should be ampere. Right. So ini sahaja the only formula yang kamu akan apply untuk subtopic number 1. Okay. So the one describe microscopic model of current, define that is for your UPS lah kalau dorang tanya lah. Okay. So the theory part UPS, tapi the calculation part PSPM lah. Okay. So sekarang Q here is basically the amount of charge lah that pass through a conductor at any location during the time interval lah. So yang ini there ada an additional formula which is Q equal to NE. Okay, yang di sini ni rasanya ada sudah di previous chapter. If you know, this is the amount ataupun number of charge, and in this case it is electron lah. This is charge of electron. Okay, so that is just the amount of charge, and then we have T, which is the time interval lah. Okay, next, on the 1 ampere sama juga macam capacitors and electrics, you have 1 farad. You also have to know what does 1 ampere means lah. Okay, so 1 ampere of current defined as 1 coulomb of charge passing through the surface area in 1 second. Macam tu je lah. And then the ammeter should be connected in series in order for us to measure the flow of current lah. Okay, and then this one is just the analogy. If there's always a difference in potential, there will always be current flow. Okay, so that's why di sini dia ada high potential, low potential, barulah ada pergerakan elektron. Pergerakan current lah maksudnya. Okay, and in terms of direction of current pula, current is always opposite to the direction of flow of electrons. Okay, so direction of current, dia akan bergerak dari positif ke negatif. Okay, so that is current. Electron pula dia akan dari negative to positive. Kenapa dia bukan positive to negative? Sebab sekarang electron is a negative charge. Obviously, it's gonna be on the negative side. Bila dia on, barulah dia akan attracted to the positive terminal. Okay? Right, so that is that. And then example ni kamu akan tengok sendirilah di lecture videos lah. So today I think we're just gonna try to do until 3.3 rasanya. Sebab kamu ada 9 subtopics. Okay, so if you have 9, we split it into 3 weeks. So basically 3 subtopic lah untuk 1 week. Okay, so untuk subtopic number 2 pula, this is on Ohm's law. Okay, untuk subtopic number 2, you only have to use Ohm's law lah. Ohm's law is just V equal to IR. Okay, so for this one, as you all know, V is going to be proportional to the current. So if voltage increase, current pun increase. Okay, so this is only valid when the physical conditions and temperature are constant lah. Physical conditions constant maksudnya dia punya type of the wire, so the resistance is constant lah. Okay, so that is Ohm's law. And then we have resistance. Resistance kalau kamu rearrange Ohm's law tu, you can then get the formula untuk resistance lah. So resistance ni apa? Resistance ni is a property lah. So it limits the current flow. Okay, so the higher the resistance, the harder for the current to flow through the wire. Okay. Example 1 to be, yeah, the amount of charge. Q equal to IT. So, and then, tamis ka dalam video. Tidak, itu they just basically bagi kamu confusion. Alright, so next. Resistance, symbol dia macam ni lah. Capacitor macam ni. So make sure kamu tidak confused lah. Mana tahu kamu tiba-tiba lupa symbol dia macam mana. Okay, lepas tu the resistance can also be determined using this formula here ni lah. Okay, so sekarang ni sorry, kamu ada dua benda yang kamu kena guna use. Kamu kena always check your learning outcomes, okay? Apa formula yang kamu akan kena test dalam exam. So kalau kamu tengok learning outcomes here, you have to use Ohm's law, use resistivity. Meaning we ada two formulas that you have to use. V equal to IR, and then we have resistivity. Resistivity is rho lah, which is this one here. Rho macam density. Okay, so this one here is known as resistivity. This is the ability of the material untuk oppose the flow of an electric current. Okay, so dia tidak mau bagi current tu jalan lah. Okay, they oppose the flow. So sekarang ni, formula dia adalah RA over L. So formula yang ini, dua formula ni is the formula yang kamu akan guna. Okay, untuk subtopic number 2. You have to use Ohm's law, use resistivity. So dua benda tu kamu akan kena tanyalah dalam PSPM. Macam tu lah. Okay. So R kamu tahu resistance, area is area je lah. L is basically the length of the material, the wire macam tu lah. Okay, so unit dia adalah ohm meter. Okay, so make sure kamu ingat resistivity unit dia ohm meter. Okay, so the resistivity depends on the type of material and the temperature. So kalau dia ada low resistivity, it is basically a good electric conductor lah. Kalau dia ada high resistivity, maksudnya dia an insulator. Okay, so dia tidak benarkan flow of current tu. So that's why the insulator. Okay, right, next. Okay, so that is 2.2 lah. So dua benda aja yang kamu perlu apply. And then we have 3.3, sorry, 3.2 pula tadi tu. This one is on variation of resistance with temperature. Okay, so yang ini, we only have one formula, which is this one here lah. So ini saja formula yang kamu akan apply. Okay, tapi walaupun formula dia macam ni je, sometimes you have to use the formula, tapi cari benda lain. Kiranya kalau kamu kena bagi R, you can also find voltage. Macam tu lah. So R is V over I. So sometimes you have to substitute V over I, V naught, I naught, 1 plus alpha, T minus T naught. Okay, so something like this lah. So, dorang selalunya suruh apply macam ni, tapi sometimes you have to substitute untuk cari benda lain. Sebab R ni dorang tidak bagi. Macam tu lah. The usual questions dalam PSPM. Okay, so on the effect of temperature, yang ini is basically gonna be on your UPS lah. Dia tanya atau tidak, kita tidak sure. Tapi again, theory is only for UPS. Okay, so that is the effect of temperature. In short, kalau the greater the temperature, the greater the metal will vibrate lah. Okay, so maksudnya di situ, kalau increase temperature, resistance will increase lah. Macam tu lah dia mau cakap. Okay, so on resistance and temperature, so we also have an equation in terms of resistivity lah. So dari mana dorang dapat ni? Dorang dapat dari rho RA over L. So dorang basically just rearrange R is rho L over A. So they substitute lah rho di sini, and then we know that the material should have a constant length and area, so dorang boleh cancel lah dengan di sebelah each other. Okay, so macam tu je lah. And then the usual temperature the question is going to give you is at 20 degrees Celsius lah. Okay, so yang itu untuk reference temperature. So basically itu initial temperature kamu. Initial temperature kamu usually at 20 degrees Celsius, but then again, it depends on the question lah. Okay, so sekarang ni kalau dorang rearrange, dorang dapat R di sini, tapi ini yang formula kamu akan apply lah. Okay, based on learning outcomes, dia suruh use ni. Tapi kalau based on experience, lecturer-lecturer yang buat soalan ni, dorang kan lecturer uni, so dorang sometimes tidak take into consideration apa learning outcomes kamu, lepas tu dia bagi pula soalan macam ni. So make sure kamu tidak terkejut lah, walaupun learning outcome suruh apply yang macam ni, tapi boleh juga dari ini dia jadi macam ni. So kamu just kena rearrange lah formula ni. Dia bukan an issue pun, you just have to remember how to rearrange untuk dapatkan in terms of resistivity. Macam tu lah. Okay, so sekarang ni R0 ni the initial, R ni final. Okay, lepas tu kita ada definition untuk temperature coefficient of resistivity, which is alpha lah. Okay, last time dalam UPS dia ada pernah tanya apa definition untuk coefficient resistivity ni. Okay, so kamu kena pilih lah mana satu yang betul. Right, so make sure kamu ingat yang itu. And then alpha ni basically dorang rearrange dari here, dari here lah. Okay, so they define it in terms of resistivity, bukan resistance. Okay, so untuk alpha ni SI unit dia adalah per degree Celsius lah. Okay, so that's it for 3.1 until 3.3. So sekarang kita ada 1, 2, 3, 4, 5. Lebih kurang 5 formula lah untuk the first 3 subtopics ni. Okay, so sekarang kita tengoklah untuk soalan tutorial. Seharusnya soalan tutorial sampai dia tidak pula kan. Cepat saya tengok jap 3.4 masuk ke sudah simplification. 3.5 baru masuk. Okay, cepat. Yang tu maybe we have to continue. 3.4 is EMF. Sampai 3.3 je. Soalan tutorial sikit je kita dapat buat. 1, 2. Okay, kejap I go through 3.4 jugalah. Supaya kita dapat solve soalan tutorial sikit. Okay, so untuk 3.4, this is on electromotive force. So electromotive force simbol dia adalah epsilon. Okay, ini dia ada persamaan dengan kamu punya chapter 2. So di sini yang budak selalu confused. Dia dorang confused sebab dorang they're always assume yang epsilon untuk soalan 2 is untuk soalan 3. Okay. Obviously memanglah ada persamaan sebab yang ini boleh written as voltage juga. Okay, tapi make sure kamu ingat balik kalau dia ada pasal dielectric constant yang bagian ni. Betul kan ni? Siapa pun tidak ingat dia punya formula. Okay, yang epsilon ni is for permittivity of dielectric material lah. Okay, tapi untuk chapter 3, which is your question 3, this is for apa nama dia ni? Electromotive force. Okay, So make sure kamu ingatlah bahagian yang itu. And then we have internal resistance. So internal resistance is small letter R lah, lowercase r. They're different lah dengan external resistor. Sebab external resistor kamu akan guna capital R. Tapi untuk internal resistance kamu mesti guna lowercase r. Potential difference is basically V lah. Okay, so V is potential difference. Yang ini electromotive force is just E lah. Cuma dalam chapter 2, battery tu dia boleh guna EMF, tapi electromotive force dengan potential difference is two different things lah. Kamu tidak boleh samakan dia. Okay, so sekarang ni untuk di sini learning outcomes kamu, you have to be able to define EMF internal resistance of a battery, that is UPS lah. Define semua ni, state factors ni, explain ni UPS. Okay, sebab kamu perlu apply formula. So the only formula you have to use here is terminal voltage. Okay, so sekarang ni what are the difference between EMF and potential difference V here? Okay, so the definition of electromotive force is the energy. Okay, sekarang ni EMF ni is energy provided by the source to each unit of charge that flows through the external and internal resistance. So EMF ni, they consider both external and internal resistance. Terminal potential difference pula, it is the work done in bringing test charge from negative to positive terminals of the battery through external resistance only. Okay, so kalau kamu tengok bahagian EMF ni, they consider external and internal. Tapi potential difference ni, they consider battery through external resistance only. Okay, so itu perbezaan dia. Right, so kalau kamu tengok di sini, terminal voltage ni, dia after dia keluar dari battery. Okay, EMF ni pula, they consider the whole supply. Okay, so that's why kalau kamu tengok EMF ni, dia akan lagi besar dari V. Sebab EMF ni is the battery, the whole battery. Dia supply berapa banyak. Then they consider juga internal resistance tu. So selepas EMF tu, kiranya lepas volt tu limpas ni internal resistance, dia akan berkurang sebab dia ada an internal drop. Okay, so known as internal drop lah. That's why terminal voltage lah. Terminal voltage ni dia kena tolak dengan IR, voltage dari loss due to this presence of internal resistance. That's why selalunya bila kita test battery tu, walaupun battery tu dia cakap 6 volt, tapi bila kita test guna voltmeter, dia tidak akan exactly 6 volt. Sebab di dalam battery ni, dia ada internal resistance. So due to the presence of this internal resistance, there will be internal drop of voltage, which is basically known as loss of volts lah. Okay, so berapa nilai internal resistance tu darab dengan current dia, itulah nilai loss volts dia. Okay, so that's why V is not equal to EMF. Okay, ini kalau ada internal resistance lah. So situation ini depends. Dia boleh ada internal resistance, dia boleh ada internal resistance. Okay, so dua formula ni, actually satu je pun formula. Okay, formula yang ini kamu kena ingat lah, and bukan ingat, rasanya ada dalam formula sheet. Kamu just have to know how to apply it lah. Okay, sebab yang ini dia akan continue sampai subtopik kita yang selepas ni. Dia sampai 3.9, 3.8. So make sure kamu understand terminal voltage ni dengan electromotive force. Okay, so assume so when there is no current flowing, we can say terminal voltage ni akan equal to electromotive force lah, sebab there's no loss volt. Okay, tapi bila ada current flow, the way we the way we determine the current. Macam mana dia dapat equation yang ini ni? Dia dapat dari V is equal to EMF minus IR. So we know that V here, kita boleh substitute dengan Ohm's law, IR. Lepas tu E ni kita letak di sini, so dari sini I. So from here, kita akan dapat current punya equation. Saya rearrange dulu. So IR plus I lowercase r, EMF. And then kamu akan dapat R plus R equal to EMF. So dari sini dapatlah equation yang ini. Okay, so this concept here, yang substitute V equal to IR ni, kamu kena ingatlah, especially on Ohm's law. Sebab again, subtopik seterusnya memang akan apply this concept. Okay, so make sure the basic here kamu faham. Okay, so untuk kamu cari current, kita boleh guna terminal voltage. Okay, tapi terminal voltage ni kita boleh relate dengan Ohm's law, which is capital IR lah. So from here untuk kita cari current yang flow through this circuit, kalau ada internal resistance, kita boleh apply yang ini. Okay, so sekarang ni, if the internal resistance is small, the current flow, the voltage, which is the terminal voltage ni, akan lebih besar lah. So kiranya kalau internal resistance rendah, voltage akan lagi higher. Macam tu je lah terminal voltage dia. Right, setakat ni okay ke? Bahagian explanation equation ni. Alright. Okay. Right. Next we have internal resistance. So internal resistance ni is just the resistance of the chemicals inside the battery lah. Kita tahu kan battery tu consists of few chemicals, and then that chemicals is the internal resistance of the battery lah. Okay, sama juga lah yang saya cakap tadi, smaller the internal resistance, the greater the current and the power the source can supply. Okay. Right. Ni apa ya? So ini symbol of EMF and this is internal resistance lah. So internal resistance ni orang akan lukis lagi kecil tau daripada external resistor. So dia punya lukisan tu pun berbeza. Okay. So that is EMF, internal resistance and potential difference lah. Saya masuk chapter 3.5 sebab supaya kamu tahu macam mana mau simplify and apa karakteristik saya lah. Okay, so untuk yang ini sama juga dengan capacitor, resistor pun boleh ada connection series and parallel. Okay, so the difference between capacitors and resistors, dorang punya equation terbalik. Kalau kamu ingat, R1 plus R2 plus R3, kalau untuk parallel, kalau untuk capacitor C1 plus C2 plus C3, yang ini untuk parallel. Tapi kalau resistor dia terbalik. Okay, kalau dia tambah ni, maksudnya yang ini untuk series. Okay, so kalau kamu mau ingat, kamu ingat tak interchange between those two? Okay, so kalau parallel C1 C2 plus C3, maksudnya kalau series, kalau parallel sudah C1 plus C2 plus C3, maksudnya dorang punya resistor kena 1 over untuk parallel. Okay, so kamu ingat macam tu lah. Pandai-pandai lah cara mau ingat tu. Yang penting kamu tidak confuse mana satu series, mana satu parallel punya equation. Okay, so untuk resistor ni, karakteristik dia yang equal is, untuk series, voltage is not equal. Okay, so basically V1 is equal to V2 equal to V3 itu hanyalah untuk parallel lah. Okay, so yang ini basically dia akan letak voltmeter lah. So volt di sini tidak akan sama. Okay, so yang ini voltage supply ni dia akan split. So V1, V2, V3. Tapi untuk parallel circuit, di voltage yang dia supply ni akan equal dengan setiap resistance. Okay, so itu characteristics untuk resistance in parallel and then resistance in series. In terms of current pula, the current untuk series circuit akan jadi equal. Okay, so kiranya cara kamu ingat kalau voltage sudah tambah, the current mesti equal. Dia tidak boleh dua-dua tambah. Sebab kalau tidak, kita tidak akan dapat this equation here. One of the characteristics tu mesti equal. Okay, so untuk series circuit, the current across each resistance will be equal. Tapi untuk parallel, dia akan split lah. So I1, I2, I3. Okay, so lepas dia substitute macam tu, so kita dapatlah equation yang ini. Okay, so always remember effective resistance kamu untuk series should always be greater than any individual resistance. Okay, so kalau 2 ohm and then kamu dapat effective resistance kamu less than 2 ohm, maksudnya kamu ada salah kira. Okay, sama juga untuk parallel, effective resistance mesti less than the smallest resistance in the group. Kalau R dia sudah 2 ohm, salah satu resistor tu, and then kamu punya effective resistance tu dapat 4 ohm untuk parallel, maksudnya salah. Sebab they should be less than 2 ohm. Okay, so itu characteristics untuk series and parallel lah. Okay, so make sure yang bahagian simplification ni should be tidak masalah lah. Nanti kamu try tengoklah lecture notes, sepatutnya kamu sudah try, kamu sudah belum, saya baru je upload. Okay, tapi tak apa, kita tengok bahagian tutorial lah. Okay, so yang ini rasanya kita boleh buat sampai 3 or 4 je questions. Kita tengok lah. Right, so kita first tutorial question, we have a 24 volt potential difference. Okay, so sekarang ni V is equal to 24 volt. And then we have a resistor of 15 ohm. So sekarang ni we have to calculate the current flowing through the resistor. Okay, so for this one, kalau kamu masih ingat Ohm's law, V is equal to I R. So from here, I is equal to V over R. So since we already have the value of V, we already have the value of R, we can just substitute into the formula. So V is 24, R is 15. So kamu akan dapat current equal to 1.6 ampere. Okay, so ini straightforward je lah, sebab kita tahu Ohm's law. And then next, we have a circuit that runs for 3 hours. So 3 hours is the time. So now we have to calculate the total number of charged particles. Total number of charged particles, that is basically the amount of charge, which is Q lah, through the resistor over that period. Okay, so untuk yang ini, kita boleh guna equation Q equal to IT. Okay, so from here, guna yang besar sikit. So yang ini kita akan guna Q equal to IT. Okay, so ini kalau kamu confused, kita dapat dari mana? IQ over T. So dari sini kita mau cari amount of charge kan? So kita rearrange lah. Q equal to I T. So that's why kamu dapat equation yang ni. Q equal to I T. So from here, current is, yang kita kira tadi, 1.6. Sekejap dia minta apa? Total number of charged particles. Total number of charged particles is N lah. Cepat, salah pula definition saya. Mana tu? Q is equal to NE. Yes, Rohi Zati. Tekan kah ada salah mau tanya? Saya pula. Okay, sini ya. Saya tulis ini adalah number of charged particles. So number of charged particles, we should cari N. Okay, so if the question mention amount of charge, barulah kita cari Q. Tapi sekarang dia minta number, specific. Dia minta specific value. Berapa banyak tu? Amount of charge tu dia tidak specific. So kita boleh cari yang tu lah. Okay, so from here, kita bukan mau Q, kita mau cari N. So, since we know Q is equal to NE, so kita boleh substitute NE equal to I T. So we are looking for N, so this is I T over E. Right, so from here, I is 1.6, time is 3 hours. Remember, hours is not SI unit. So, kita perlu convert pergi second. So, times 60 divide by the charge of electron, which is 1.6 times 10 negative 19. Okay, so from here, the number of charge particle is 1.08 times 10 to the power of 23 electrons. Okay, okay, so again, amount is not equal to number. Okay, sebab amount ni dia specific. Dia sekarang minta specifically berapa banyak charge yang limpas the resistor. Macam tu lah. So that's why dia minta number. So berapa banyak amount ni dia just bagi rough value. Okay, yang ini dia minta the exact value. Alright, any question here? Boleh? Okay, good. Next, kita tengok soalan 2. So for question 2, we have a potential difference of 8 volt. Okay, so sekarang dia bagi V 8 volt supplied across a 20 degrees Celsius iron wire with uniform cross-sectional area of 0.08 millimeter square and then length of 0.5 meter. Okay, so sekarang soalan minta kita cari resistivity of the iron wire if the current flow is 1.2 ampere. Okay, so sekarang dia bagi, sudahlah di sini, temperature coefficient of resistivity 0.005 per degree Celsius. Okay. Yes, amount of charge is Q. Number of charge is N. Okay. So sekarang ni, kita ada V. V is given as 8 volt across a 20 degrees Celsius iron wire, and then the cross-sectional area is given as 0.08 millimeter square. Milli kamu kena convert pergi meter square, so that is negative 3 times 2 here, so kamu akan dapat 10 negative 6 meter square. And then dia bagi length of the wire, which is 0.5 meter. Okay, so dia minta resistivity and then dia bagi kita temperature 20 degree Celsius. Kalau kamu ingat, nota tulis number of charge also Q. Tengok balik definition di lecture notes. Di sini dia mention amount of charge, okay? Huh? Yeah, N. Number of charge particles. Apa saya cakap, bukan memang saya sebut number of charge particles ke?
If the question is number of charge instead of amount of charge and number of charge particles, then number of charge is Q kan?
Amount of charge is Q. You mean kalau dia tulis particles, dia Q?
Ya. Ya kak?
Dia sure lah yang tu. Dari mana kau dapat tu information? Boleh je saya tanya kami punya subject matter expert. Sebab should be number of charge is still N. Tapi yang saya tanya Encik Nazar dulu, which is subject matter expert. Sa bahagian definition ni, tidak sure. Tapi should be kalau dia minta number of charge, kamu kena ingat use N je lah. Tapi saya double check lah. Okay, Anderson? Okay. Right. So sekarang ni kita tahu temperature is always usually at 20 degrees Celsius. So this is our reference temperature. Okay. Reference temperature is T naught lah. Okay. So from here, the question asks us to determine the resistivity. Okay. So given is the current, which is 1.2 ampere. So sekarang ni kita ada resistivity is just, what's the formula resistivity? RA over L. Okay, RA over L. Japan, method of track. Yes, RA over L. Okay, so but the problem here is we do not have the value of resistance. So macam mana kita mau cari R? Again, kita akan masukkan Ohm's law. Okay, so Ohm's law ni, V equal to IR ni, dia sentiasa ada kena guna. Okay, sebab dorang ni suka kamu ke substitute dari formula dari subtopik berbeza. Okay, so itu untuk soalan chapter 3 ni. So from here we know that R is gonna be V over I. So from here you can then just substitute draw V over I A over L. Okay, so adakah tidak V, adakah I? Ada, which is 8 and then I is given as 1.2 lah. So from here, rho is, this is 8, this is 1.2, area is 0.08 times 10 negative 6. L is given as, mana L? Oh, 0.5. Okay, so from here, resistivity is 1.07 times 10 to the power of negative 6 ohm meter. Okay, so itu untuk resistivity. Next, okay kah ni? Boleh kah? Kamu sedang menyalin kah? Kamu screenshot? Okay. So soalan B, we have, after leaving the circuit closed for an hour, it was found that the electric current decreases by 0.001 ampere. Determine the change in temperature of the iron wire. Okay, so sekarang ni, kalau soalan minta change in temperature, kita ada satu formula je yang ada delta T, which is the resistivity punya formula lah, which is R equal to R naught 1 plus alpha delta T. So kalau kamu ingat, this is gonna be R naught 1 plus alpha T minus T naught. So T naught ni basically dia punya initial temperature lah. R naught ni adalah initial resistance. Okay. So from here, since kita tiada value of R, kita akan again apply V over I lah, which is the Ohm's law. V over I. This one is V I naught. Kenapa V saya tidak letak V naught di sini? Sebab V yang kena supply ni masih lagi constant. Okay, dia masih sama. Battery yang sama. Potential difference yang sama lah kiranya. Okay, tapi current dia di sini, kenapa I? Sebab dia tulis di sini dia ada decreases by 0.001 ampere. So the current is not the same. Okay, so from here, 1 plus alpha, 1 plus alpha T minus T naught, then kamu just substitute lah. So current ni dia cakap decreases by 0.001. So kita kena tolak 1.2 ni, tolak 0.001. Okay, so voltage dia ni masih lagi sama. Yang ini 8, ini 1.2 lah. So from here, we are looking for delta T lah. Oh, ya kan? Kenapa saya expand lah tadi? So yang ini 0.005. And then this is delta T je lah. Okay, so we are looking for the change in temperature, which is delta T. Okay, so kalau kamu substitute dalam calculator, you will then get delta T equal to 0.167 degree Celsius. Okay, okay kah di sini? Q. And Jepang. Okay, so next question, question 3. Okay, this one. Okay, so this one, we have a battery. So given the EMF is 15 volt. Okay, so sekarang ni internal resistance is 4 ohm. Okay, so it is connected to a resistor of resistance 6 ohm. Okay, so sekarang ni, the way they differentiate between internal and external resistance is dia punya symbol here. So kalau dia small letter R is internal, external resistor is capital R. Okay, so sekarang ni dia suruh kita cari the reading of ammeter and voltmeter in the circuit above. So basically suruh kita cari V dengan terminal voltage dengan dia punya flow of current lah, current dia berapa. Okay, so sekarang ni we cannot directly use V equal to IR lah. Okay, boleh je pun. Cuma untuk current, maksud saya untuk current. So sekarang kita try cari current dulu lah sebab dia minta ammeter kan. Okay, so sekarang ni we have to find the value of current. We can use terminal voltage lah. V is equal to EMF minus IR. Okay, so from here we only need to find I. But the problem is we do not have the value of V. Okay, so sekarang ni it's either kamu cari V dulu ataupun kamu cari I dulu. Sebab selepas kamu cari I, kamu boleh cari V. Tapi the problem is, in order for us to find V, we need the value of I. Okay, so sekarang ni apa yang kita perlu solve dulu is the current lah. So macam ni kita mau solve yang ni, we know that V here is equal to IR. So we can substitute EMF minus IR. So dari sini rearrange lah. So I capital R plus I lowercase r equal to EMF. So current is just EMF external plus internal resistor. So kamu akan dapat EMF dia sudah bagi situ, which is 15. And then this one is then we have external 6 plus 4, which will then give you the current equal to 1.5 ampere. Okay. So lepas dapat current, barulah kita dapat cari reading of voltmeter, which is 1.5, external is 6. Okay, so from here, V is equal to 9 volt. Okay, so yang ni straightforward juga lah, cuma kamu kena guna dua formula. Satu yang ini, dan substitute ni dalam ni untuk cari I. Sebab kita ada dua unknown sekarang. Kita tiada I, kita tiada V. Okay, so that's why kita kena guna dua formula. Alright, next, explain why the voltmeter reading is different from the EMF of the battery. Ya, kenapa dia tanya soalan explanation di sini? Okay, so yang ini basically why is because yeah, so the voltmeter reading is the reading of the terminal voltage. Kamu paham ka tulisannya? Boleh ba 'to? Okay, so why is there a difference? Because the difference is due to the energy required to drive each coulomb coulomb of charge through the materials of the battery. Ini jawapan answer schema. Macam tu. Okay. Basically, kenapa ada difference is basically due to the presence of internal resistance lah. Okay, so when current flow through the internal resistance, they will be some loss of volts lah. Okay, macam tu je ba tu jawapan dia. Tapi ini jawapan answer scheme lah. So, saya ikut je lah jawapan answer scheme. Okay, so that is on explanation. And then lastly, we have how much energy will be dissipated by the resistor. Energy? Ano ka dalam nota saya energy? Itu subtopic mo na energy. Diba? Sige, itu 3.7 na. Okay lah guys, terpaksa kita teruskan juga. Okay, so untuk energy kita itu subtopic 3.7 lah. Tapi nanti saya akan explain juga. Tapi untuk cari energy, we have this equation here lah. Okay, so this is the equation, either these two equations lah. Okay. They combine lah pula. Lupa. So from here untuk energy is W. Okay, formula dia kita ada dua, VIT or WI square RT. So it depends on what information is available lah. So sekarang ni dia bagi sudah lah the value of time. Dia minta after 65 seconds. Okay, so from here kamu pilih je lah mau kiri atau kanan. Okay, so jawapan dia sepatutnya sama aja lah. So I'm just gonna use the first one. V is equal to 9. Current is 1.5. This is 65 seconds lah. Okay. So from here, work pula. The energy dissipated is 8.8 times 10 to the power of 2 joule. Okay, so that is for energy. All right. And then 3 questions, huh? Lepas ni kamu ada kelas kah? Class face to face. Tiada. Ada. Kalau ada, we are gonna continue. Iya, question 4 pun sudah 3.7. Okay lah, kita continue tomorrow during our second hour. Yeah, during our second hour. Okay. So, kalau boleh kamu tengok lecture videos sebab soalan tutorial kita ni dia tidak ikut subtopic, dia combine all subtopics. Okay. So, start tengok lecture videos and then solve all the examples in the lecture notes. Right? So, that's all for today. Untuk yang number of charge, amount of charge to subject matter expert untuk fisik belum reply. Kalau dia sudah reply, dan saya bagi tahu lah tomorrow's update time tutorial. Alright, so that's all. Thank you, everyone. Sige la, class.